Hello, I'm Dr. Margaret Fourney from Athlone Institute of Technology in Ireland, and we are leading a major pan-European Chinese research effort aimed at tackling plastic pollution. We all know that plastic pollution is a global crisis of prestigious proportions. Our team includes 9 countries, spanning the map of Europe, from Ireland and Portugal in the west, then Spain, Germany, the Netherlands and Belgium, and over to Serbia and Greece in the east, and then on to Shandong and Beijing in China. The project is called BioICEP, which is Bioinnovation of a Circular Economy for Plastics. BioICEP is jointly funded by the European Commission through the Horizon 2020 programme and the National Science Foundation of China. Plastics have been intensely developed since the early 1950s, and great work has been done to make them as good as they are today. One critical aspect is that during this time period, we didn't address what to do with them when we were finished using them, how to deal with them post-use. Plastics can take centuries to degrade in the natural environment, and this is now threatening the well-being of our planet. The BioICEP project is designed to degrade waste plastics naturally. Our team of experts are working to generate new green technologies to degrade and digest plastics biologically, and then regenerate them as new sustainable plastics and bioproducts. In essence, we'll be taking in mixed plastics at one end, treating it mechanically, green chemically, with bacteria and then enzymes, and then recovering the constituent molecules and building blocks, and making these into a feedstock to biosynthesize new sustainable bioplastics and biopolymers that will not be harmful to the environment. The BioICEP project will play an instrumental role in the quest to resolving the global plastics crisis. And added to this, it will have the benefit of spurring new technology developments and further low carbon economic growth and job creation, and all the while mitigating against plastic pollution and preserving the world's natural resources.
Hello, my name is Lorna Walsh from Athlone Institute of Technology. I'm the project manager for the BioICEP project, which is funded under Horizon 2020. Being part of the BioICEP for me is like being backstage at a major theatrical performance. I get to work alongside wonderful scientists from Europe and China and support and watch them develop groundbreaking research for new sustainable plastics, which will ultimately be a game changer for society and plastics. I get to manage and support all this work and to assist in the final act, which is to create new technological developments in a quest to resolve the global plastics crisis and in turn make the next generation of plastics which will not harm our environment.
My name is Dr. Declan Devine and I'm the Director of the Materials Research Institute in Athlone Institute of Technology. Here in Athlone IT, we have about 50 years of experience in polymer engineering. And it's because of this and the applied nature of our research gives us a unique interaction with industry, where they use our expertise to advise them on where the future is going within the field of plastics engineering. Polymers are everywhere. They're from the clothes we wear to the phones we use for everyday applications. This is due to unique properties such as lightweight and low cost. But one of the problems with plastics is that they don't rot or rust like conventional materials, and they're designed to last for up to 1,000 years. So a problem comes when we use these for single-use applications, such as food application, where they're used once and then thrown away. However, without plastics, food would rot much faster and global food shortages would be exacerbated. The BioICEP project is looking to tackle this problem by taking conventional plastics and using natural processes to degrade and rot them, so that we can use them as feedstock for new conventional plastics which have better properties and are more environmentally friendly, thereby closing the circular loop within the plastics waste cycle.
I'm Dr. Yuanyuan Chen, a polymer research engineer with AIT. I'm also the liaison officer for BioICEP to support the efficient communication between the European and Chinese partners. BioICEP is a European-Chinese collaborative project. We have 3 Chinese partners who are funded by the National Natural Science of China. Professor Qiqing Sheng from Shandong University is leading the Chinese consortiums. He is well noted in metabolic engineering and synthetic biology of microorganisms. Professor Yang Yu from Beijing Institute of Technology is one of the first to demonstrate mixed plastic pollution being degraded by waxworms and mealworms. Professor Tang Shangyan is the Deputy Director of the Laboratory of Microbial Physiological and Metallic Engineering in Chinese Academy of Science. She is an expert in enzyme engineering and biosynthesis of high-value small molecules. So the European-Chinese partners are working hand-in-hand to develop a solution for mixed plastic pollutions.
Hola, soy Ángel Martínez, soy el director de la división de reciclado de Azteco y soy también el responsable del proyecto BioICEP en Azteco. Azteco es una empresa dedicada a buscar e implantar soluciones medioambientales a todo tipo de residuo industrial, tanto preconsumo como postconsumo. Mi trabajo en el proyecto BioICEP está centrado en la tarea 3.1 y la tarea 3.4. La tarea 3.1 consiste en el análisis y la formulación de los residuos plásticos que van a servir de materia prima para el proyecto. Tendremos que hacer un informe, el deliberable en el mes 6, sobre esta tarea. Luego la tarea 3.4 significa, o hay que hacer el análisis también de los productos que han sido pretratados y toda la caracterización de aquellos productos que han sido degradados y aislados.
Mi nombre es Pablo Ferrero, vengo de AIMPLAS, centro tecnológico situado en Valencia, España. AIMPLAS participa en diferentes paquetes de trabajo. Nosotros nos vamos a centrar más en el pretratamiento de los materiales plásticos para facilitar la degradación enzimática y microbiana y seremos los líderes en diferentes tareas en estos paquetes de trabajo, por ejemplo en la degradación térmica asistida por microondas, en la depolimerización asistida por CO2 en estado supercrítico o la extrusión reactiva. Y además también seremos los líderes del paquete de trabajo de diseminación, comunicación y explotación de los resultados.
I'm Strakhir. I work for Avicom, a Belgium R&D-driven SME. So I'm a bioengineer in environmental sciences, and as project engineer I have nearly 20 years of experience in controlling microbial processes, optimizing and steering microbial processes. I have expertise in remediation technologies, soil remediation, water remediation, but we also have a lot of experience in processes in the circular economy, valorization of nutrients, microbial production of proteins, production of microbial PHA. And so BioICEP really fits into the core business of Avicom, the circular economy, and within BioICEP we will try to upscale the work of the partners. At lab scale we will scale up into the BioICEP pilot plant.
My name is Christos Sargerosis. I'm representing the Clausthal University of Technology. There I am member of the Clausthal Material Science Center, and I'm visiting professor since several years. The Clausthal University of Technology is involved in 2 work packages. In work package 2 we will perform the pre-treatment of the plastics using ultrasounds, and in the work package 3 we will be investigating the surface signs after treatment as resulted from the treatment with ultrasounds, but also we will investigate the surface changes after the bioenzymatic treatment done in the National Technical University of Athens.
My name is Yasmina Nicolai and I'm from Belgrade, Serbia. I come from the Institute of Molecular Genetics and Genetical Engineering as a part of the University of Belgrade. I lead the team of young researchers from the Institute of Molecular Genetics and Genetic Engineering, and our role in the BioICEP project is mainly dealing with the enzymatic and biocatalytical degradation of plastic waste materials. We are trying to develop new biocatalysts, new enzymes, and improved biocatalytical processes for the bioplastic degradation.
I'm Maria Reis. I'm a full professor at the Nova University, Lisbon, in Portugal. In this project, IBET is used as a platform between the university and the industry, and our role in this project is to develop a process to convert waste material, plastic waste material, into biodegradable polymers, rhamnoliptids, and nanocelluloses. Also, we are committed to develop a metabolic model to do the optimization of the process.
I am Dr. Sushantkumar Shetty. I come from Limerick Institute of Technology. Limerick Institute of Technology has 5 dynamic campuses with about 6,500 students, and it has several research centers, including the research center called Shannon Applied Biotechnology Center, where the BioICEP project research activities will be undertaken. As a partner of this project, LIT, LIT's project leader is Patrick Murray. Myself, Sushantkumar Shetty, and Catherine Collins are involved in biodiscovery screening of our biobank, where we have the fungal isolates, we have the microalgae and cyanobacterial isolates, and also during the project tenure, we will be going to the environmental site where we'll find the contaminated plastics and isolate the potential organisms that may be bacteria, fungi, cyanobacteria, and microalgae, and we'll be screening their potential for biodegradation, and eventually we'll come up with a consortium of organism, and that is potential of biodegradation of plastic and through the various depolymerase enzymes that we'll be characterizing, and also we will be characterizing their potential to produce other form of biopolymers that is actually biodegradable and should be sustainably produced during the project.
Eu sou o João, venho de Portugal e pertenço à empresa Logoplast Innovation Lab. O Logoplast Innovation Lab é uma empresa do grupo Logoplast que se encarrega de fazer o desenvolvimento de garrafas, levando-as desde um conceito de design até à sua produção num protótipo capaz de ser industrializado. E vamos utilizar essas capacidades neste projeto de maneira a validar se as matérias-primas que queremos desenvolver neste consórcio podem ser utilizadas a nível industrial, fazendo-os passar por um processo de validação pelas tecnologias existentes, percebendo se elas têm capacidade para ser produzidas, se têm as características químicas e físicas necessárias para que elas possam incorporar garrafas e possam depois ser transportadas para um ambiente industrial para serem utilizadas pelos clientes finais.
So my name is Joel De Boer. I'm actually from the Netherlands, and I represent a small biotech company called Microlife Solutions. So in the BioICEP project, Microlife Solution actually has 2 roles. The first role is as leader of Work Package 6. And in Work Package 6, what we want to do is we want to look at microbial communities, either the ones that we can find in nature or the ones that we can make ourselves, and see how they can degrade various forms of plastics. And the other role is actually to be active in the degradation work packages, where we want to test our microbial and fungal strains to see if single strains produce enzymes that can break down plastics.
My name is Evaculostopakas. I'm coming from National Technical University of Athens, School of Chemical Engineering, where I work as an associate professor. So National Technical University of Athens will focus on the discovery of novel enzymatic activities as well as novel protocols for assaying enzymatic activities in order to discover microbial strains that are able to degrade synthetic polymeric materials.
Yeah, my name is Ramesh Babu. I'm from Trinity College in Dublin, Ireland. As a part of BioICEP project, we are looking at developing a pre-treatment technologies to degrade this mixed plastic waste to convert into high-value products, so that our other partners can develop new technologies to upgrade this mixed plastic waste into biodegradable polymers or lipids or nanocellulose.